All right, so today we're going to be going over the quadratic formula. That is a formula that can be used to solve quadratic equations. So that formula here is x equals negative b plus or minus the square root of the quantity b squared minus 4ac, closed quantity, all divided by 2a. So that is a chunk to remember. Typically, a lot of the time, Algebra 2 classes will ask you to remember that. I will ask you to remember that. There is a weird way that people use to kind of memorize this. You can kind of sing it along to the tune of Pop Goes the Weasel. That's the song when you play a Jack in the Box that goes something like this. I don't know how well you were able to hear that there, but it goes along the lines of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a little bit weird, but that might help you memorize it. So kind of along that just a little something different. So that goes back to this quadratic equation. It only works when you have the quadratic set equal to 0. So we can use it to solve problems like x squared plus 5x plus 6 equals 0. So the first thing we're going to want to do is solve and identify a, b, and c. We've done this before. A is the coefficient of the quadratic term. Here we just have x squared. So the coefficient of that, since there's no number written in front of it, is 1. B here is 5, the coefficient of x, the linear term, and c is the constant, which is 6. So now we're going to substitute that in to this equation. So we've got x equals negative b, which means b is, if b is 5, negative b is negative 5, plus or minus the square root of b squared, which is 5. I always put b squared in parentheses. I put the b in parentheses and then square it to make sure that I have that correct. Minus 4 times a, which is 1, times c, which is 6. All over 2a, which is 1. So then we simplify what we can. Negative 5 is just going to stay as negative 5. We're going to simplify what goes in the radical. So I try to do this all in one step when I have the ability to. So just type in what is in the radical. 5 squared minus 4 times 1 times 6. And that comes out just to be 1. All over 2 times 1, which we know is 2. So now, a couple of things. One, we know what the square root of 1 is. Sometimes this will simplify down and we need to continue further. So the square root of 1 is 1. If you don't believe me, try the calculator. Square root of 1 is 1. And we have a plus or minus sign here. Sometimes that plus or minus sign will stay in your answer, but if you can work it further down, then that's what we're going to do. So we actually go to 2 different places here. We're going to do exactly what it says. Negative 5 plus or minus. So we're going to do negative 5 plus 1 because it's square root of 1 all over 2. And we're going to do negative 5 minus 1 all over 2. So sometimes we leave it in this form, but because we can find the square root of 1, we are going to break it down into the plus and the minus 2 different versions. So then negative 5 plus 1 is negative 4. And negative 5 minus 1 is negative 6. And those are both divisible, so we get negative 2 and -3. So there are two answers that make this equation true. This is actually a factorable quadratic, but I showed one way that we could solve this using the quadratic formula another way. So if x is -2, this equation is going to be true, and it's also true when x is equal to -3. You usually get two answers for this. One other somewhat helpful thing that you can do is to find what is called the discriminant first. Remember when we went and typed that whole 5 squared minus 4 times 1 times 6 to get the 1 inside the square root? That is something that is sometimes useful. If we find that, then it simplifies this problem a little bit more. -b plus or minus the square root of the discriminant all over 2a. So we could try that here in our second example by finding the discriminant first and seeing if we can simplify that. So here again, we want to identify a, b, and c. We know a is 2 because that's the coefficient of x squared. B is -4. Make sure you get your signs right there because it's the coefficient of x. And c is -7. Again, get your signs correct. So now, instead of going straight into the whole quadratic formula, we're just going to find the discriminant. So d is equal to b squared minus 4a, which is 2, times c, which is -7. So then we've got -4, again, I want to put that in parentheses, squared, minus 4 times 2 times -7, and that comes out to be 72. So our discriminant is 72. And now we can go into this more simplified version of the quadratic formula. X equals -b. B is already negative. So if b is -4, that means I want to put a +4 here, plus or minus the square root of the discriminant, which in this case is 72, all over 2a, which in this case is 2. Next, again, we want to simplify what we can. So I'm going to kind of write over here, we want to simplify the square root of 72. Now, I don't think that has a whole number as its square root, but it never hurts to check. Might be a good idea to see if you can take that down to a whole number. The square root of 72 does not simplify that way. And so this is where we're going to have to go back to what we did a little while ago, where we made a factor tree for the number 72. I'm going to do that off to the side over here. So 72, there are a couple of ways you can factor 72 down. Maybe the most simple is 2 times 36. We know it's an even number. 36 breaks down as 2 and 18. 18 breaks down as 2 and 9. And 9 breaks down as 3 and 3. So then we've got 4 plus or minus the square root of, remember how we did this, 2 times 2 times 2 times 3 times 3. All over 2 times 2, which is 4. Then we're looking for couples that can get married. We have a pair of 2s here that can get married and a pair of 3s here that can get married. So we have 4 plus or minus 2 times 3. Remember, that pair of 2s becomes 1 and moves out. That pair of 3s becomes 1 and moves out. And we have this 1, 2 left under the radical, all over 4. We can break that down. 2 times 3 is 6. So we have 4 plus or minus 6 radical 2 all over 4. And then the last thing here, occasionally we will need to do this. We're going to look at each of these 3 terms. We've got 4, 4, and 6 right there. If those have anything in common, we need to simplify those as well. We can divide 2 out of all of them. So a simpler version of this is 2 plus or minus 3 radical 2 all over 2. So I'm going to leave my answer like this. I divided 2 out of 4, which left me with 2. 2 out of 6, which left me with 3. And 2 out of 4, which left me with 2. So my answer is 2 plus or minus 3 radical 2 all over 2. That would give me my 2 answers, and this is the exact form I'd like to leave that in. So if you have 2 answers like this, you could just say your answers are -2 and -3. Here, that doesn't break down into anything other than really a decimal at this point, so that is where I'm going to leave it. And you can type your answer in on GoFormative when we do our homework on there using a plus or minus sign. If you pull up the keyboard, you can type in a fraction with 2 plus or minus 3 radical 2 in the numerator and 2 in the denominator. So keep in mind that you can type your answer in that way. And hopefully that takes care of us for today. We'll look at another way to use the quadratic formula in our next video.